Hi. In our previous section, we have discussed Wheatstone Bridge in balanced condition. Now, we're discussing about Wheatstone Bridge in unbalanced condition. Unbalanced condition means if there is a current flows through the galvanometer, then we can say that bridge is in unbalanced condition. That means unbalanced means current flows through the galvanometer. If there is any current flows through the meter, then we can say that that is unbalanced. If no current flows through the meter, then we can say that that is in balanced. If current flows, then that is unbalanced. Now we'll see here again, we'll see the existence of Wheatstone bridge in unbalanced case. In this unbalanced case, we have to determine the amount of current flows through the galvanometer. How much amount of current is flows through the galvanometer? That's we have to find in this case. So in this case, just I'm having a resistors like this. For again, I'm drawing Wheatstone bridge with four arms. These are the four arms, and between the terminals, here it is A, B, C, D. Four terminals are here. Between the terminals A and B, we're having DC source. Between the terminals C and D, we're having galvanometer. Galvanometer is here. Now I am naming these resistors as R1, R2, R3, R4, and it is E, and it is E. Now, to determine the amount of current flows through the galvanometer, we had to convert this circuit into Thevenin's equivalent model, Thevenin's equivalent representation. To analysis into Thevenin's equivalent representation, we had to find Thevenin's equivalent voltage and Thevenin's equivalent resistance. Those are the two values we had to find here. So to find those two values, I'm assuming here I'm calculating. I'm assuming here A and B are the two terminals, and I'm assuming EA is the potential at point A, EB is the potential at point B. A and EB are the potentials at the point B. To find the voltage in between these two, that means Thevenin's equivalent voltage will be obtained here, EA minus EB. EA minus EB. Then we will get that Thevenin's equivalent voltage. So for this aspect, I am calculating here Thevenin's equivalent voltage. Now here we have to find the voltage. How much amount of voltage we have here? So for that, to calculate that one, I am using voltage divider formula. Voltage divider formula. That means now I'm getting here EA. That means potential at point A. Potential at point A. That means from this point to this point. Actually, the potential divider formula is applied voltage into across resistance by total resistance. That is the voltage divider formula. That is how much amount of voltage we are applying here. That is the first point. And after that, where we are calculating the voltage, that means across that resistance. Here EA is calculating across R3, so it is the across resistance here. And the total resistance, that means in this branch, the total resistance is R1 and R3. That is the point. So EA is equal to applied voltage E into across resistance R3 by total resistance R1 plus R3. It is EA. Similarly, EB equal to, that means now I am calculating this point and this point. That means this point and this point. In between these 2 points, I am calculating again applied voltage into, now across resistance is R4 by total resistance. That means now the path is this is the path. Total resistance is R2 plus R4. Now Thevenin's equivalent voltage ETH is equal to EA minus EB. EA minus EB. Now the value of EA is here, EB is here. So E into R3 by R1 plus R3 minus E into R4 by R2 plus R4. I'm taking E as a common term. E into, here the rest of the term is R3 by R1 plus R3 minus R4 by R2 plus R4. It is ETH, Thevenin's equivalent voltage. Now I had to find Thevenin's equivalent resistance. Thevenin's equivalent resistance I had to calculate. To calculate Thevenin's equivalent resistance, the source should be short circuited. The source should be short circuited. That means here this is the source. This source should be short circuited to find the value of total, that means the Thevenin's resistance. So the circuit can be redrawn as follows. Here it is the circuit right now. In this case it is the circuit. Now I'm having R1, R2, R3, R4. Now the source is short circuited. Look at here, source is short circuited, and the values R1, R2, R3, R4, and the points here. This is point A and this is point B. Those are the 2 points we're having. Now I'm rearranging this particular circuit as, that means rearrange this one as like this. Here I'm rearranging like this. Look at here. Here simply can rearrange like this. Here it is R1, R2, R3, R4, R4. And now look at here. Here R1, R2. In between R1, R2, we have one terminal of source. This is the source terminal, and in between R3 and R4, we're having another terminal of source, and in between R1 and R3 we're having A. In between R1 R3 we're having A. In between R2 and R4 we're having B. R2 and R4, in between those two are having B. So now with this, just See here. Now these two resistors are in parallel to each other. That means this one and this one. These two are in parallel, and at the same time these two are in parallel, and these two combinations, this one and this one, these two are in series to each other. It is parallel, it is parallel, and these two are in series to each other. So the Thevenin's equivalent resistance RTH can be given as these two are in parallel. So R1 parallel R3, this combination, and this combination is also parallel, R2 parallel R4, and these two combinations are in series, that means plus. And finally I'm writing as R1 R3 by the parallel combination R1 R3 by R1 plus R3 plus R2 R4 by R2 plus R4. It is Thevenin's equivalent resistance. Thevenin's equivalent resistance. Here we have determined RTH and VTH. Now the modified circuit can be seems like this. Here it is RTH and it is ETH. It is RTH and it is ETH. With these two values, the Thevenin's equivalent current ITH can be given as ETH by RTH. It is the amount of current flows through the galvanometer. For example, if we have meter resistance, meter resistance, meter resistance means galvanometer resistance, that is Rg. If we have galvanometer resistance Rg, then this formula can be written as ITH is equal to ETH by RTH plus Rg. Just simply add this galvanometer resistance. It is the formula for current flows through the galvanometer.